Hello, skis pre-cal world. Today we're going to be talking about section 1.2. This is talking about analyzing graphs. First thing that you need to know are things called symmetry tests. Keyword, if you see prove it algebraically, this is what we are looking for. So if you were to take the point x negative y, it would be the same thing as the regular point x, y. That is if you have x-axis, and this is if you plug it in your function. So pretty much you're plugging in a negative y for your y value, and if it comes out the same as your regular function, you are good to go, and you have x-axis symmetry, which would look something like that. Y-axis symmetry, same token, but you will make the x negative. Origin, you will take both of them to be negative. Y-axis symmetry looks like that. Origin symmetry looks like that. Take a second, pause the video, get this down, and here you go. First example I'm going to look at today with you guys is you will be given a picture, or you can graph your picture in your calculator. But if you are given the picture and it is asking for the domain and the range, don't forget your domain is your x values, your range is your y values. D comes before R in the alphabet, just like X comes before Y in the alphabet, however you want to remember that. And remember, we are going to be given this in interval notation. So it looks like for my domain, the lowest x value that I have is negative 1, 2, 3, 4, 5. So I go from negative 5 to infinity, because it is increasing to the right the entire way. And my range, it looks like the lowest y value I have is 1, 2, 3, with that also inclusive. So I'll put a bracket. So negative 3 to infinity. Arshis. Yay? Yay. Yeah, you got it. Woo! Okay, again, make sure you guys are pausing the video. Actually try these. Write the example down. Try it, and then you can check the solution. The more you do that, the better you'll get, the more you will understand it, the more you can actually use these videos to help you rather than just writing stuff down and not even understanding what I'm talking about. Or if you have a question, come ask a question. It's always better to ask a question. I promise I will never throw a shoe at you. I can't say the same about your college professor, but I won't. Okay, so this one, again, talking about just domain and range. For your domain, looks like the lowest x value we have is negative 2. Notice that is not inclusive, so make sure you put a parenthesis. So negative 2 to 1, 2, 3, 4. Negative 2 to 4, with 4 being inclusive. Your range, your lowest value is also not inclusive, so you have negative 3 to 4. Notice that is the 4 up there, right? Not the 4 over there. Okay. Yay. If you have questions, let us know, please. I promise. We love you. Y'all are boos and bays. All right, this one's a little bit trickier, but we'll just have to pay attention. So domain, orange. So my domain, it looks like my lowest value I have negative 1, 2, 3, 4, 5. So I go from negative 5 to 1, 2, 3. So negative 5 to negative 3, where negative 3 is inclusive. And, don't forget union just means and. Looks like negative 1 to 1. And then from 1, 2, 3 to infinity. Oh yeah! Hey! Hey! Okay, and then the range, we have negative 1, 2, 3, 4, 5 is our lowest. It is included. So negative 5 up to, that's about negative 4. There's not included. And then I have 0 to 1 where all of that's included. So union 0 to 1. Union 1, 2, 3. Also 3 to infinity. And there it is. All right, jumping into a different type of problem. Just in case you guys haven't noticed, I have this weird, like crazy, weird thing. I don't even know what it is. Well, I do know what it is, but I don't know why. I don't know. I just write it really fast. It means example. So it just means I'm doing a different example, just in case you haven't picked up on that yet. That's okay. Anyways, so this one is asking for the x and y intercepts. Don't forget the x-intercept is where it touches on the x-axis because it is intercepting the x, right? Yeah. And the y-intercept is where it crosses the y-axis. So what I can do is my y-intercept is going to be the easiest one. So let's say for the y-intercept, I know that I'm going to have 0, comma, some number. Right, because if it's on the y-axis, then my x value has to be 0. So if I just plug in 0 for all my x values, yeah, then I have f of 0 is 0 cubed plus 6 times 0 squared plus 9 times 0. Well, That's just 0 added 3 times. So my y-intercept is going to be the point 0, 0, right? Yay, there it is. If you want to, it kind of looks like a not so sure face. You can make it a monkey. Put a little hair on him. Yeah. Woo, yeah. Right, not so sure monkey. Cool. And for our x-intercepts, well, that is when we don't know the x value, but we know our y value is going to be 0 because it's going to be on the x-axis. So I can put in a 0 for my f of x, which just means the function value, or my y value. So I have 0 equals x cubed plus 6x squared plus 9x. Well, by factoring this thing, we'll factor out an x first. So I have x squared plus 6x plus 9. And then I can factor that because that is a perfect square. So I have x times x plus 3 times x plus 3, which is the same thing as x times x plus 3 squared. So my zeros here, well, I have something times something equals 0, so x equals 0 and x plus 3 equals 0. So I have x equals negative 3, that would be a double root, and x equals 0. This would have a multiplicity of 2 because of that. We'll talk about that later. That is not in this unit. And there she is. Yeah. Oh, but I didn't write them as ordered pairs. So make sure intercept, x-intercept. So we have 0, 0. Should have been obvious by that one. And negative 3, 0. Cool. So we would be looking for these two, and we would also be looking for that. Don't draw a monkey unless you want your other teacher to be confused. And they will. All right, x and y-intercepts again. Again, for your y-intercept, same sort of deal. Plug in a 0 for the x and whatever the y comes out to be. So we have g of 0 equals the square root of 0 minus 1. So g of 0 is the square root of negative 1, which is actually just imaginary. So we will say no y-intercepts. Box it, circle it, whatever you want to do it. And then for your x-intercepts, you have 0 equals square root of x minus 1. You can square both sides, so you have 0 equals x minus 1. So x equals 1, therefore your x-intercept is 1, 0. And there we go. Okay, our first one where we are going to determine symmetry, and we're actually going to do this algebraically. So when you see the words prove algebraically, this is what we are talking about. This is what we want to see on your paper. And even odd. I didn't talk about that in the beginning, but it's real simple. If it has even symmetry, it is y-axis symmetry. If it has an odd function, it is the origin symmetry. I will also give you a definition after this example of another way to check for even and odd functions if that is the only thing you have to do. But if you have to check for symmetry anyways, well, you might as well figure out the symmetry and that'll tell you whether it's an even or odd function. So with this, I kind of have a feeling that if it is, it probably is y-axis symmetry. So don't forget, for y-axis symmetry, we're going to plug in a negative x value. So banana phone. So if I have a negative x value and everything else stays the same, I have negative x squared plus 6 times negative x plus 10. So f of negative x equals x squared minus 6x plus 10. Now, the question you have to ask yourself is this the exact same function that we had at the beginning? Does f of negative x equal f of x? Well, no, because this sign is different. Up in my original function, it is plus 6x. Down in my new function, when I plugged in negative x, it is minus 6x. So,
Mr. Sudbrick, can you please come to the book room? Mr. Sudbrick,
oh, Mr. Sudbrick's in trouble. Okay, so this would not be y-axis symmetry. Y-axis, no. Okay, next thing we can do is test whether it is x-axis symmetry. Let's use a color other than blue. So that was testing y-axis. Let's test x-axis. So for x-axis symmetry, I would plug in a negative y, so negative f of x equals x squared plus 6x plus 10. If I solve for f of x here, then I have f of x equals negative x squared minus 6x minus 10. Well, every sign changed from the original function, so this is not x-axis. The last one we can check is origin symmetry. So if I have negative f of x, negative f of negative x, then I would end up with this function, x squared minus 6x plus 10, and then I would divide by the negative 1, so f of x would be negative x squared plus 6x minus 10. Well, it's kind of close, but again, that sign is different and that sign is different, so it is not origin symmetry. So this actually has no symmetry. If you have a calculator, you could also plug it in your calculator really quick and just determine it that way. But if you need to prove it algebraically, we want to see all three methods tried, attempted, and failed. All right, let's do another one of these guys. So determine symmetry, even, odd. I kind of have a hunch again that this might be y-axis if it's anything. So if I try y-axis symmetry, I have a negative x value. So I'll say f of negative x equals negative x to the fourth plus negative x squared plus 3, which would come out as x to the fourth plus x squared plus 3. So check it out. This sign is the same. X to the fourth, same the same. This is the same. This is the same from both of them. So since they are all the same, that means we do indeed have y-axis symmetry. So y-axis symmetry is good. If it is y-axis symmetry, that also means it is an even function. Yay. Oh, sorry, I forgot to tell you I was going to do the definitions. Oh, no. Oh, no. Okay, for an even function, if you plug in negative x, it will come out as f of x. For an odd function, if you plug in negative x, it will come out as the negative function. Okay, so we saw that in even. That's what we did, right? We plugged in a negative x, right? Negative x, negative x, negative x, came out as the same signs. All of the signs are the same as the original function, therefore it is an even function. Let's look at one that might come out odd. Well, we don't know until we do it, do we? No, we don't know. Come on. I have no idea. I'm so sorry. I don't know. All right, here's the next example we're going to look at. Same sort of deal, determining symmetry and whether it's even or odd function. So I kind of have an inkling, right? You'll get better at these. Just kind of guess and check. That's all you can do. But I kind of think it might be x-axis symmetry if it is anything. Actually, I lied. I think it might be origin symmetry if it is anything. So if it is origin symmetry, don't forget that's when you plug in a negative x and a negative y value and try to get it to come out to be the original function. So we will say negative h of negative x equals negative x cubed plus negative x. And in distributing the negatives, I have negative h of negative x equals negative x cubed minus x. And if I divide by negative 1, then I have h of negative x equals x cubed plus x. Well, hey-o, again, check it out. This is the same as my original function. So since it came out, my signs are good, they are the same, then this is definitely origin symmetry, which would make this an odd function. Okay, I will show you the way to test that for just odd. So this is just testing it if it asks to show that it's an odd. I don't know what I just said. Hopefully it makes sense. I'm so sorry if it doesn't. If it doesn't, just come ask me questions. I promise I'll answer them. I love you all. Okay, so this is testing for just to see if it's an odd function. I'm not really testing symmetry, but just seeing if it's an odd function. So this came out negative x cubed minus x. This was h of negative x. And notice, just like our definition of an odd function, if I plug in a negative x, it comes out as negative the function, which just means to me that all the signs change. All signs change. If you want to write that. Yay, pause, yay. I'm not going to pause. I'm going to keep going. I'm going to keep talking like a fool. Yep, I just said a whole sentence. You have no idea what I said, though. But check it out. We have negative x cubed and negative x. In our original function, we had positive x cubed and positive x. So all these signs are different from my original function. Therefore, again, we have proven that it is an odd function. Okay, hopefully this video was helpful and informative for you guys, not too terribly long, not too terribly stupid. I apologize that I'm kind of silly. Hopefully it keeps everything light and funny and you smile and you are ashamed that you're watching this video in front of your friends and they're like, what is that? But they're really curious, they just want to know what's going on. Ha! Happy homeworking! Bye-bye!